Hello friends, welcome to our channel Knowledge Amplifier. So in our previous video, we already discussed in detail on how to publish message in a particular Kafka topic from AWS Lambda, and where our Kafka is basically Amazon MSK Cluster, right? That is basically kind of acting like a producer site. If you want to know that detailed explanations, you can go through the link given in the description box. So today in this particular video, let us try to understand how to build the consumer side. That is, whenever messages will be coming in a particular topic in our MSK cluster, then automatically the AWS Lambda code should be getting triggered. Okay. And in that Lambda code, we can basically execute different business requirements. Like for example, suppose the messages are getting landed in a particular topic in our Kafka cluster. This Kafka cluster is nothing but our MSK cluster. Now, if we able to trigger the AWS Lambda code directly, then might be from Lambda we need to call one separate API which will do some processing in external HTTP or HTTPS server. That kind of business requirement we can solve if we able to integrate the trigger functionality with MSK cluster and Lambda, right? Then, for example, suppose whatever messages are getting landed in a particular topic in our MSK cluster, suppose we want to store all of them in an RDBMS system, okay, or in DynamoDB, whatever these kind of database systems if you want to store, then obviously this particular trigger can help us. If direct trigger from MSK to Lambda is possible, then obviously we can solve this kind of business requirement or business scenarios very easily, right? Then another example can be analytics purpose, right? So what we need that whenever messages are getting landed in a particular topic, we want to store them in real time in our S3 location. So what we can do, if from MSK directly Lambda code can be triggered, so that Lambda code will read all those messages, whatever will come as part of event, and then it will maybe do some modifications or structuring of those JSON data and then write in particular S3 destination location. So this kind of integration we can easily build using Amazon MSK trigger and Lambda code. Okay, so let's try to understand how we can trigger Lambda code as in when messages are getting published in a particular MSK topic. Okay, we will do the lab from scratch, but before jumping to the lab experiment, I would like to discuss little bit theory, and that is Amazon MSK, as we know, it is a highly available service. So it must be configured to run in minimum 2 AZ in your preferred region. Okay. So obviously it is not like suppose you have 3 Kafka brokers running, and if all 3 are available in same AZ, then what problem you might encounter? That is due to some reason, if the region has some problem, if the AZ goes down, then the whole cluster will go down because all the servers are available in same AZ, right? So to make MSK highly available service, at least we need to configure brokers in 2 different availability zones. As we know already from our previous video also, we configured in 2 different AZ, right? Another important point is security aspect, right? So to comply with security based practices, the brokers or the Kafka servers are usually configured in private subnets in each region. Okay. So in our previous video, when we published messages from AWS Lambda to a particular MSK topic, that time we created the MSK cluster in public subnets. Okay. But that is just a POC we were doing. We are trying to understand how to set up the integration and all. But in real-time projects, we don't set up brokers in public subnets, but rather those are configured in private subnets. Okay. So this particular diagram can help you to visualize the architecture in a better way. So here we are having our AWS cloud. Within cloud, we are having our virtual private cloud. In that VPC, suppose we have 2 different AZ. So what will happen that within that VPC, we will create 2 private subnets. Okay. And suppose we want to have only 2 brokers running for our MSK. So one broker will run in one private subnet in availability zone 1. Another broker will run in some other AZ. Like here it is showing that this broker is running in availability zone 2. So that if there is some problem in AZ1, at least the cluster will be still accessible using the AZ2 broker. Okay. And another important point, as you can see in this diagram, that the brokers are configured in the private subnet. And that particular concept only written here. That is, to comply with security based practices, the brokers are usually configured in private subnet in each region, not in public subnet. Okay, right? Cool. Now for Amazon MSK to Lambda, you must ensure that there is a NAT gateway running in public subnet of each region. So what I mean to say using this line is, our requirement is whenever messages are getting published in a particular Kafka topic, our Lambda code should be getting triggered. Like earlier we did lot of experiments, right? For example, as in when the files are getting landed in S3, the Lambda code should be triggered. So that time we configure S3 trigger for Lambda. Similarly, if you want to have that kind of mechanism where whenever the messages are getting published in a particular MSK topic, your Lambda code should run. In that case, if your MSK brokers are running in private subnet, you need to make sure that NAT gateway is available. And using NAT gateway, basically private subnet will able to communicate with Lambda. If you don't have NAT gateway, the private subnets cannot trigger our Lambda functionality. That's what is written in the third point. That is, for Amazon MSK to invoke Lambda, you must ensure that there is a NAT gateway running in public subnet of each region. Okay. So here, as this particular picture is showing, we are having 2 AZ. So in 2 AZ, 2 NAT gateways are running. Okay, right? I hope you can easily understand this. Now it is possible to route the traffic to a single NAT gateway also in any of 1 AZ for test and development workloads. Okay, so what I mean to say is, for example, if you consider this particular diagram, here we are having 2 brokers in 2 different AZ. But suppose you are working in development environment or QA environment or test environment, and as we know that NAT gateway need to allocate one elastic IP which charges. So what we can do for those kind of dev or test environment, we can keep only one NAT gateway in any of 1 AZ. And if we basically set up that NAT gateway integration with private subnet in route table, then also our MSK topic will trigger our Lambda code as and when messages are getting published in that topic. Okay. But for production environment, when you will go, you need to make sure that NAT gateway is available in each AZ separately. That's what is written in the last point. That is, for redundancy in the production workloads, it is recommended that there is one NAT gateway available in each availability zones. Okay, right? So this is the bit theory. What we understood, that we will be having one VPC. Within that VPC, we will be creating 4 subnets. One public subnet will be creating in 1 AZ, another public subnet will create in another AZ, and one private subnet we will create in 1 AZ, another private subnet we will create in another AZ. Okay, and then we will launch our MSK cluster in those private subnets, and the private subnets will talk to our Lambda using NAT gateway. Obviously, NAT gateway will be available in public subnet. We will just configure the route table for private subnet, and we will configure such that if any request is coming from internet, it should go via NAT gateway. Okay, right? Cool. So this particular architecture, I hope it makes sense to you. Now, without any further delay, let us directly jump into the lab section. Okay. So here in this Notepad++ file, I have written these steps. I will go through this. I will share these steps in the description box or in the comment section also, so that you can parallelly do the hands-on and get the complete feeling out of this particular discussion. Okay. So let's see the step 1. So what is the step 1 we are doing? We are creating a virtual private cloud, and the name we are giving virtual private cloud Lambda. Okay. The IPv4 CIDR range we are providing 11.0.0.0/16. /16 when I am giving, that means first 2 octet we cannot use, only the last 2 octets can be varied for IP range. So obviously the host address range can be 11.0.0.1 to 11.0.255.254, as you can easily understand from our previous discussion. And if you are not aware of the networking part, you can brush up the fundamental concepts of networking from my previous videos. I'll be sharing those links in the prerequisite section in the description box. Okay, cool. So here what I will do first, I will create our VPC. So that VPC, within that all these subnets and all these NAT gateways, MSKs will be residing. So let's start our lab with the VPC creation. So here I will go to VPC and I will quickly create one. Okay. So here I will go to VPC, create VPC, and here I will give the name, and then here this is basically our IPv4 CIDR. I will provide that, and here we are doing the experiment with US East 1 region, that is North Virginia. That is fine. You can choose any region which is nearest to your main company base location, right? So here IPv4 CIDR range we have provided, and we will create the VPC. Okay, perfect. Now what we will do, as per this particular diagram, you can easily understand we need 4 subnets, 2 public, 2 private. Okay, so that's what I have written here, that we will create 2 public subnet. Public subnet A lambda is the first public subnet name, and the another one having name public subnet B lambda. The IP range for the first public subnet we are providing 11.0.0.0/24. That is basically meaning that the host range for this particular subnet A in public region will be 11.0.0.1 to 11.0.0.254. That is only the last octet can vary, right? Because here we are giving /24. That means first 3 octets will be constant. Okay, and point to be noted, this particular base IP is obviously subset of our main IPv4 CIDR for our VPC, which has to be obviously satisfied. Otherwise, this subnet will not be part of this VPC itself, right? Then the second public subnet, I just changed this particular value, and here for this second public subnet, we will assign this as IPv4 CIDR. So that way, our host range for the second public subnet will be 11.0.1.1 to 11.0.1.254. And here, point to be noted that public subnet A we will launch in AWS East 1A. Another public subnet should be in other AZ. So here we are going to launch that in AWS East 1B. Like that same way, we will launch one private subnet in AWS East 1A, one private subnet in AWS East 1B. Every time I just changed the third value. Okay, that's all. So let's just quickly create the subnets within this particular VPC. So here I will go to subnets, create subnet. First I will choose the VPC. So this is the VPC what just now we created, and here subnet name I will give public subnet A lambda, right? And here this is basically the IPv4 CIDR range. AZ I will choose AWS East 1A, and IPv4 CIDR range I have chosen. I will just follow the same approach and create all other public subnets. So here VPC chosen, and the name is public subnet B lambda. The IPv4 CIDR range is this. Okay, AZ should be AWS East 1B, and here we have given the second one. That is done. Now here I will create the private subnet A. So VPC we have chosen, private subnet A lambda, and basically this is the IPv4 CIDR range. So for this particular private subnet A lambda, the region will be AWS East 1A, right? So that's what I have chosen, and here I have configured the IPv4 CIDR. So we will create the subnet, and the last one also we will create following the same way. Okay, cool. Pretty much very simple. I hope up to this you are able to follow, and hope in the upcoming concepts also you will be with me. So here I have chosen another AZ, that is basically AWS East 1B, IPv4 CIDR we have provided, and basically we will create the subnet. Okay, cool. So 4 subnets we have created, 2 public, 2 private, and 1 public, 1 private is AWS East 1A region, another public, another private is in AWS East 1B region. As simple as that. Okay, right? Now what we created, that has no difference. Just the name is different, but as of now we have not configured the routing such that one will be considered as public, another one will be considered as private. Okay, what makes a particular subnet public or private is depending on whether the subnet has internet gateway connectivity or not, right? So what we will do now, we will create the IGW and will attach to our VPC what just now we created. Okay, so here what I will do, I will go to internet gateway, and here I will create the internet gateway demo yt lambda test again. Okay, so this is the internet gateway I'll create, and here I will attach to our VPC what just now we created. Okay, right? Now this internet gateway is done. Now what is the next step? Obviously, as you can see that we are having public subnets, private subnets. So private subnets will not be allowed direct access to internet, but public subnets will have direct connection to internet using internet gateway, right? So what we will do, we will create 2 routing tables. One routing table will be handling both of these public subnets. Another routing table will be handling both of these private subnets. Okay, right? So here we will go to route tables, and we will now do this step, that is create 2 route tables, for one for public, one for private. Okay, right? So here what I will do, I will create the route tables. So here I can give the name as public route table. The VPC I will choose this VPC, and here I will create the table. Okay. By default it will have local connectivity, but because this is public route table, so what we will do, we will allow internet access using IGW. Okay. Just now what we created, right? So this is the one. We will save the changes. Now what is the next step? That public subnets should follow this particular route table. So for that we will go to subnet association. We will click on edit subnet association, and we will choose our public subnet B lambda and here public subnet A lambda, so that they will follow this public route table. Okay, cool. Here we will save the association. Perfect. Now what we will do, we will create another route table following the same kind of naming convention. Create route table, and here instead of public I will give private. Okay, private route table. The VPC we will choose the one what we created. We will create the route table. Okay, perfect. Now it is having only local connection, right? And here we will add the private subnets. So private subnet B lambda and private subnet A lambda. Okay, we will save the association. So that way, now these subnets have routing table attached. The public subnets have internet access via IGW, where the private subnets not having that access. Okay, right? Now what is the step 5? The step 5 is we will launch MSK cluster in private subnet. But before that, let me do one thing that I already told you, right? That we need to make sure that the private subnets have NAT gateway access, and that I have basically written in step 6. As you can see, that create NAT gateway in public subnet and attach with private subnet route table. So let me do this beforehand, before creating our MSK cluster. Okay, right? So here what I will do, I will go to NAT gateway and create NAT gateway. Maybe I can give demo YT lambda trigger. Okay, right? Subnet. So obviously NAT gateway has to be present in a public subnet, right? So maybe for example, I will choose public subnet A lambda. For example, this one, public subnet A lambda. This one I have chosen. Now I will allocate one elastic IP. So obviously it will take some charge. So please make sure all the resources you are deleting post the lab experiment. Okay, right? So here we will create the NAT gateway. Once it is created, I will go back to route tables, and for our private route table, I will attach the NAT gateway. Okay, so that the private subnets also can access internet. Okay, 0.0 here NAT gateway, sorry, not local. NAT gateway, and this is the one. Here we will save the changes. Okay, right, perfect. So with this, our networking setup is done. Now the next step is we have to launch the MSK cluster. So I will quickly open MSK. And here I'll create the cluster, custom create, demo YT lambda test 123, some name I have given. Provision cluster we want to create. Apache Kafka configuration I am keeping as it is, as we did in our previous video also. Now the broker type, because this is a POC, I will choose T3 small. Okay, number of zones 2, broker per zone is 1. Okay, so in 2 zone, 1 broker per zone, that means we will be having 2 total brokers distributed evenly across our 2 AZ, what we just now created. Okay, right? Now here this is, we are doing POC, so I will keep 1 GB storage. Okay, then click on next. Now here I will choose our VPC, just now what we created, that is virtual private cloud lambda, and then here we will choose our AZ. Okay, first zone, so in US East 1A, I will choose the private zone, that is basically private subnet A lambda, and the second one zone is US East 1B for higher availability, and the subnet what we are going to choose, again the private one, private subnet B lambda. Okay, right? Public access is off, obviously. Let it create a default security group, so we will keep this as it is. I will click on next. Now here, because already our MSK brokers will be running in a private subnet, so we no need to much worry on the security part. As of now, I am keeping unauthenticated access, but obviously you can explore other functionalities, other access control, other encryptions also. Okay, but let's keep it very simple. Plain text encryption, unauthenticated access to the cluster we are allowing. Within the cluster, TLS encryption is fine. Now I will click on next. Here, keep these properties as default. Click on next. Just review once before final launch. It looks pretty much good. Unauthenticated access is enabled. Plain text is enabled. Now without any further delay, what we will do, we will create the cluster. Okay, right? So with this, what happened, that this complete diagram setup is ready. That is, we launched an VPC instance. Within the VPC, in two different AZ, we created one public subnet, one private subnet, another public subnet, another private subnet. We launched our MSK brokers in private subnets. Okay, right? I hope up to this it is pretty much clear. Now, the next thing should be, we need to create a topic in this particular MSK cluster. Okay, now to create the topic, we need to have some client machine, right? So what we will do, we will launch one EC2 instance in this private subnet. Okay, cool. So here what I will do, I will open AWS Management Console in a new tab. Let the cluster get created. It will take 15 to 20 minutes. We'll come back to this page later. And here first what we will do, we will click to EC2. And then here first we will create a client machine so that we can basically install Java in it and download all the Kafka required files. And then we can create a topic to our MSK cluster. Okay. So here I will choose instance, launch instance. Okay. And then here maybe I can give private EC2 client. Okay. Let it be Linux machine only, not a problem. Instance type T2 micro is fine. Key pair. So I will create a new key pair. Key pair name demo lambda ytn, and then here maybe let me download the ppk file. I will create the key pair file. Okay, so it is downloaded, perfectly fine. And now here in the networking section, we need to make sure that our client machine is launched in the same VPC where our MSK is running. Then only the integration will set up, right? So I will just edit this. I will make sure I am choosing the same VPC which I used while launching MSK, that is Virtual Private Cloud Lambda, this one. Okay, this subnet, obviously we need to choose one private subnet because this is a private EC2 what we are launching, right? So here for example, let me choose private subnet A lambda. Okay, suppose I am choosing this one. Okay, cool. And auto assign public IP. So this we are launching a private EC2 instance. We don't need access via internet. So public IP not required, right? Now what we'll do, you'll scroll below and here launch the instance. Okay, fine. I hope up to this you can easily understand why we launched this EC2 instance, just to create a topic in our MSK cluster. Okay, because without client machine we cannot do that. Okay, so this is our ppk file. Let me just generate the pem file also with it, because pem file is required. If you see, if I check on this and then let it first create, then I will show you. So it is still in pending state. So here it is in running state. Suppose I want to connect to this particular private EC2, I can click on this and click on connect. So obviously we will not have direct access like putty. So if you go to SSH client, here you see that we need the PEM file. Okay, and we need to do SSH from our console. Now how we can do SSH? This is not a Mac machine, right? This is Windows machine. So what we will do, to do SSH, first we will launch one public EC2 instance. From that public EC2, we will do SSH in the private EC2. Okay. So what I will do, I will just open our EC2 console and I will launch one public EC2. Okay, right? Public EC2 lambda n, for example. Linux machine only I am keeping. T2 micro is fine. Just now what key pair we created, that only I am going to choose. That is basically this one. Okay. And then here networking. So this particular one we are launching a public EC2. So I will choose my VPC and I will choose a subnet which is public. For example, public subnet A lambda. This one I am choosing. Okay. And this I need access via internet because this is a public EC2. So I will assign the public IP and then here I will launch the instance. Okay, right? So in this public EC2, we can easily enter using putty, and from that public EC2, we will do SSH in our private EC2. Okay, but to do SSH in private EC2, we need the PEM file. But as of now, we have the PPK file. So let's convert this PPK file to PEM file. Okay, so for that, what I will do, I will launch putty gen, and then here I will load the file what just now we created in downloads, it will be there. Okay, that is done. Now I will click on conversion, and here I will choose export open SSH key. I'll click on yes. I will basically go to desktop. In maybe hippo folder I will save this demo lambda test, or maybe for example let me keep simple name efgh.pem. okay, so this is the PEM file what we can use. Now putTgen is no longer required. I can close this one. I can go to instance. So here our public and private both EC2s are running. So as a first step, what we will do, we will open WinSCP and we will move that particular PEM file to our public EC2. Okay, so that from public EC2 using that particular PEM file we can do SSH in our private EC2. Okay, right? So here I will copy my public IP. I will open WinSCP. I'll provide the host name. Because this is Linux machine, the username will be obviously EC2 user, and we are trying to enter in public EC2, right? So we can directly use the ppk file, authentication, this one, chosen, click on OK, login. So here this side is basically our public EC2 instance, right? Now what we will do, just now we created this particular PEM file, so I will just move that, drag and drop. Okay, now this particular PEM file is available in our public EC2. Now we can do all possible activity. So first what I will do, I will launch putty, and then here I will provide the host name for our public EC2, and I will choose our ppk file to enter in this and log in as EC2 user. Okay, right? So here we entered in our public EC2. From public EC2 we can do SSH to our private EC2. So here I can click on connect. So first step, we need to execute this command. Okay, but the PEM file is having this name, so I will just remove this name, and here I will give the name efgh.pem. Okay, right? The first step is done. Now I will do SSH. Okay, so here the PEM file name I will just update. Yes, and here we entered in our private EC2 instance. Okay, to make sure we are not having timeout issue, I will increase the value to 10, and here I will apply. Now here from this particular private EC2 instance, if we do ping google.com, it will work, and the reason for its work is we have attached NAT gateway in the routing table for our private subnet, right? So that's why it is working. So it is fine. Now what we will do, I will basically do all this installation. That is, we need to create the topic, right, in our MSK cluster. So for that Java is required, because to create the topic we will run a Kafka code, and to run Kafka we need Java. So I will just install these things, and the next thing is basically we will download the Kafka part. So let it do. Once it is done, we will unzip that, and then once that is done, what we will do, we will enter in this directory, and here you see all the folders are available inside which the codes are available. So we can use kafka topic.sh command to create a topic having name, for example, demo testing 2. In the bootstrap server we can provide our MSK bootstrap servers, and here partition 2 we are keeping replication factor 1, but obviously we can keep replication factor 2 because we are having two brokers. So for the same topic, one partition, whatever data will be having in one broker, the same data will be replicated in another broker, so that it will become more fault tolerant. Okay, right? But there is one catch, that this particular private EC2 client machine is having a different security, and our MSK cluster is having different security. So to make sure they can communicate between each other perfectly fine way, what we need to do, we need to make sure the security group handshake is happening properly. that all traffic from MSK security group should be allowed to our private EC2 instance security group, and from private EC2 instance security group all traffic should be allowed to our MSK cluster security group. So that we will configure. Okay, right? So let me just quickly do that. So for our MSK cluster, this is the security group. I will click on that, and then here I will edit the inbound rule, add rule. I want to make sure all traffic is allowed from our private EC2 instance. So what is our private EC2 instance? Close this window. So private EC2 instance is this one. I will go inside this. I will go to security part. This is the security group for our private EC2 instance, right? So what I will do, I will basically configure that in our MSK security group. Okay, all traffic should be allowed in our MSK cluster from private EC2. So I will save this. Now the same thing we have to do for our EC2 security group. So for our EC2 security group, this is the one. So here what I will do, I will go inside this. I will edit the inbound rule. I will add all traffic to this EC2 from MSK cluster. So our MSK cluster is having this particular security group. I will copy that one, and here I will paste this. Okay, right? I'll save this. So that way from private EC2 to our MSK, all traffic will be allowed. Similarly, from MSK to our private EC2 client machine, all traffic will be allowed. Okay, right? I hope you got the point. So here, let's see what is the status for our MSK cluster. It is still getting created. Okay, right? So here, all the steps we have followed. If you see that we have launched the MSK cluster, we created the NAT gateway in public subnet, and we attached that to private subnet route table. We launched an EC2 instance in public subnet in same VPC as of MSK cluster in a public subnet, and we launched one EC2 instance in private subnet in same VPC as of MSK cluster in private subnet. And then here we added the private EC2 security group and MSK security group both way all traffic, so that they will have no issue in communicating between each other. Okay, right? And then we entered in public subnet, and from there we entered in private subnet using SSH. We did all these installations, and now let's see the next step. So the next step is basically we will do a local testing. Local testing in the sense we will treat our EC2 client machine, and there only we will start console producer and console consumer, and we will see whether the messages are going from producer to consumer in real time or not. That way we can understand at least our networking side is perfect. Once that is done, we will move to our Lambda code. The Lambda code is pretty much simple. If you see here, I will just show you the Lambda code. So whenever from MSK topic, the event getting triggered to Lambda, one sample event can be like this way. Okay. So what is their event source is AWS Kafka. Source ARN will be having. Bootstrap servers will be having basically the Kafka server URLs, whatever our MSK cluster is having. Within that, we'll be having a key called records. Okay. And then records will be one JSON data. Within that, the key will be the partition key. See, suppose for example, our topic name is demo testing 2. Then from this name itself, you can understand what is this. Demo testing 2 -0. That is basically indicating the partition 0 for our demo testing 2. So that's why I am naming this particular variable as partition key, which is basically indicating the topic partition. Okay, that name it is defining, right? And that is basically one array. Within that, if you see the topic name, partition, offset, timestamp, what is the value? That is what message was actually published in that topic. But that will be coming in base 64 encoded format. So obviously we need to decode that in our Lambda code, right? So this is a sample event. So once you get this kind of sample event, you can basically write a simple Python code to get the actual data. So the code can be shown like this way. Import base 64, because base 64 is required because we need to decode the value which is coming in encoded format. We are importing both and JSON if it is required. And in our Lambda handler, we are first printing the event. Just to show you, it is totally optional for debugging purpose. You can ignore this. Then here what we are doing, in event of records, we are iterating in partition key. So in our case, partition key is basically demo testing 2.0. Like that, we might have demo testing 2.1, demo testing 2.3, whatever partitions. Maybe for some other topic also it might be available. So here we are iterating in that partition key. Within that partition key, as you can clearly see, this is basically one array type data. So what we are doing, we are first extracting the value part. What is our value part? Our value part is basically the complete array. Okay. in that complete array, we are iterating. So if you see here, we have extracted the array, then here we are iterating. In each iteration, we are taking the value part, because here if you see within the array, one single element, if you observe, the value part contain our actual message. So that component we have extracted, and then here we are decoding using base64.decode, right? And then here, after doing base64.decode to our that data, we will be getting bytes data. So to convert the bytes to string, we are using .decode method. As simple as that. Okay, cool. So what I will do, I will create the Lambda also. But let's see first whether our cluster is ready or not. So our cluster is still in creating state. So let me just quickly create the Lambda function also. So here I will go to Lambda and create the function. So for example, demo yt night lambda kafka. Some random name I have given. Python 3.9 execution environment I am choosing, and here I will create the function. Okay, cool. Now the next step is I will just copy this particular piece of code and I will paste in my Lambda. So here it is done. We will deploy this one. So this Lambda code should be getting triggered as and when messages are coming to our MSK topic. So we'll add the trigger, but before that we will do some small changes. For example, the timeout we will increase bit so that it will not have timeout issue. And the next thing is in the permission section, we need to add some permission. For example, MSK access we need to add. And all these things are running within VPC, right? So for safer side, we should be giving the VPC access also. So I will attach the policies, and here I will search MSK. Here you can see Amazon Lambda MSK execution role. I will just choose that. I will attach the policy. And then the next policy what I will attach, that is VPC. Okay. So here Amazon VPC full access as of now I am keeping, right? So here IAM role for Lambda is done. I can close that window. Perfect. Now what we will do, once our cluster is ready, we will do the trigger part. So here you see our cluster is ready. I will click on that, and here few client information. So here I will be getting our broker URLs, right? Now first step what we will do, we will create a topic in it, and the topic will be having name, for example, demo testing 2. Okay. Here in the Bootstrap server, I have pasted these values. I will copy this particular code to create the topic using Kafka topic.sh. We are already inside our client machine, which is basically launched in that private subnet, okay, within the same VPC. And here first I will create the topic. Hope it will not throw any error. See, the topic got successfully created. Okay, now we will start a producer consumer and we will locally test first whether it is working or not. So what I will do, I will duplicate this session, okay, and log in as EC2 user. Okay, so if we duplicate the session, we will just reach up to the public EC2. Then we have to enter in private EC2 also, right? So for entering in private EC2, we will just execute the SSH command once again in that new terminal. So here I will go to instance, and then here this is our private EC2. I will just click on connect, and here I will choose this particular SSH. Just let me do ls. So the PEM file name is having this particular one. So I will just make sure we are giving the same name. Okay. So here we entered in our private EC2 instance. Now what I will do, I will enter in this directory, okay, where our Kafka is there. Now I will start the consumer. So to start the consumer, this is the simple code Kafka console consumer.sh. We are providing the topic name, and now here we need to provide the Bootstrap server URLs also. So here we have provided. I will just copy this one, and then here I will start. Okay. So here our consumer is started. I will just minimize that, and here what I will do, I will copy the Bootstrap server URLs for our producer also, and here I will start the producer. So here I will copy this one, and then here I will start the producer. So here what is happening, in this window our producer is running, and in this window our consumer is running. Let's just test it out whether it is working or not. So hello world. Okay, if I am passing, see in consumer in real time the message is going. Hi, this is second one. Some spelling mistake might be there, ignore. So here this integration is perfectly working. Now we are good to set up our trigger for Lambda. Okay, right? This is a very vital step. So I'll go to Lambda, I'll add the trigger, and here I will choose MSK. Okay, I will just choose MSK cluster. I have chosen this one. Batch size I am keeping 10. So let it accumulate at least 10 message. And the starting position I am keeping latest, so that only the latest messages will be consumed, not from beginning. Same like Kinesis, what we discussed, latest and trim horizon, these two options are there. Cool. Batch window, for how much time it will wait to accumulate the data. For example, 5 seconds we are keeping. Topic name. So in our case, the topic name is basically this one. I will give the topic name. Consumer group ID, I am not keeping. Let Lambda automatically create that. Okay. And now we are good to go to add the trigger. Okay. Because we have set up the NAT gateway in our private EC2, that's why this particular setup or this particular trigger from topic to Lambda will work. Otherwise, if you have not configured the NAT gateway, it will not work. Okay, right? So the state is in creating state. We have to wait a little bit until and unless the state is changed to enabled state. Okay, right? So let's wait for a couple of seconds. So here if you see, now the state is changed to enabled. Okay, right? Now what we will do, it's time to test. So here we are having our producer consumer. Anyway, this consumer is a separate consumer and our Lambda is a separate consumer. Now the expectation is, if we are publishing some message in using this particular producer in this particular topic that is having the name demo testing 2, then the message should be going to Lambda also. Okay, or Lambda should be getting triggered. Hello Lambda, this is the message I have published. So anyway, in this particular consumer also it is coming, that is fine. This is second one. Hi there. And then some number, maybe I can publish 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And then maybe some JSON data I can publish. Hello world. Okay. And then here, hi Python. For example, randomly I am publishing something. So now let's test it out whether our Lambda got triggered or not. So obviously it will not be triggered immediately because we have configured that either 10 messages accumulate or wait for 5 seconds, then only trigger, right? So let's see, I think it should be triggered at least once by this time. We'll click on few logs in CloudWatch and fingers crossed. So see here, one log file got generated. Let's click on that and see here all the messages are coming. Hello Lambda, hi there, this is second one. Some batching happened, that's why all these messages are printed one by one. Then here, hello world, hi Python. This kind of JSON data is also coming. Okay, that's the beauty. That now, as soon as messages are coming in a topic, from that MSK, automatically our Lambda get triggered. Okay, generally what happens, we need to create a consumer which is running 24/7 and maintaining that, monitoring that is a complex hectic operation. But this architecture is complete serverless. In a serverless manner, we can consume the data from topic in an event-driven manner, and then we can write in S3 or we can store that in any DBMS system. For example, I can publish some more message. For example, like I can publish GH, some random data I am publishing. Okay, KV. Okay, our channel name, maybe let me publish. Okay, so here it is coming. Then for example, Java is a good language. FS. Okay, some more random values I have sent. Let's see whether it is coming to Lambda or not. So see here, GH, that message came, KV came. Then here our channel name, what we published, that is knowledge amplifier came. Maybe if we refresh, we will get other messages also. So see here, FS, and then Java is a good language. All these things are coming, right? So I hope you understood how to trigger the AWS Lambda, Python code, or any other programming language as per your choice, as and when messages are coming in our MSK topic, right? And don't forget to terminate the NAT gateway, because their elastic IP is associated, so obviously it might cost some charges in your account. So please terminate the NAT gateway, release the elastic IP, terminate all the EC2 instances, terminate the MSK cluster to avoid unnecessary cost. And all these steps what we followed in this particular video, this particular notepad++ file is having all of them. I will share this with all the necessary resources which you can explore to have more knowledge in this Lambda trigger from MSK. So this is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.